Hello students, today we are going to discuss about objects as instances and access specifiers. Now why do we call objects as instances of a class? We have studied about class and objects in the previous classes also, that a class is a group of objects which have common properties. It is a template or blueprint from which objects are created. As we know that objects are the part of the class and class serves as only the blueprint for the objects, and the class state and behavior is exhibited by the objects. So we say that objects are the instances or the part of the class. Next is creating objects or instantiating objects. An object in Java is a block of memory that contains space to store all the instance variable. We know object is a part of the class and variables and the methods that we declare inside the class are also the part of the objects. And the process of object creation is known as instantiating an object or creating an object. The general syntax for object creation is the class name space object name is equal to new space class name. Here new is the operator that is used for creating the object in the memory. And the example of object creation is rectangle space rect1. Here rect1 is the object of the class rectangle, and this statement is known as object declaration. And also rect1 is the reference to the rectangle class object. Therefore, we say that classes are the reference data types also and the user defined data types also. Here, the variable are the object and the data types are the name of the class. Therefore, we say that objects are the variables of the type class, or classes are the user defined data types. Next, we can see, coming back to this example, rect1 is the object of the class rectangle. Rect1 is equal to new rectangle means we have created an instance rect1 of the class rectangle, and now we have created a reference of this object. This is a diagram form of that previous example. Action is declaration, statement is rectangle space rect1. When we declare the object of any class, only a space is given and it does not contain any reference to the object of the class. Next, when we instantiated that object with the help of new operator, a memory is allocated to the rectangle object. Now it has created a reference to the rectangle object. And here rect1 is the reference. Let us have a quick recap of instance variables, class variables, and local variables. Here data is the name of the class. Data1 and data2 are the instance variables as they are declared inside the class, but they are not preceded by the keyword static. Data3 and data4 are class variables as they are declared inside the class with the keyword static. Void display data is the instance method because it is not defined with the help of static keyword. Data1 and data2 are the local variables because they are declared inside the method. Next, what is the difference between instance methods and static methods? Instance methods are used to perform repetitive tasks like reading records from the file, reading records from the DBMS. See, when we have to do the task again and again, repeat the task multiple times, and we can define the instance methods. Otherwise, when we need to perform a single operation like opening the files and obtaining a DBMS connection, we need to define static methods. Means when a function is to be done once only throughout the task, it must be defined in the static method. Second, method definition does not require a static keyword to start. Yes, here net salary is the static is not a non is not a static method because it is not preceded by the keyword static. Whereas in the column of static method you can see basic salary is the header of this function is defined with the static keyword, therefore here basic salary is the static method. Third point, in instance method each and every instance method must be assessed with the respective object name. Instance method needs the name of the object to be called, whereas the static method are also known as the class members, therefore they need the class name to be assessed. Fourth point, the result of instance method is not shared. Every object has its own copy of the instance method. As the instance methods, the objects, there are number of objects of one class, and the instance variables and instance method have different copies depending on the number of the objects they are created, whereas the class methods are having the same copy as as they are shareable among the different objects. Kindly note the non-static methods can assess both the instance variables as well as class variables, whereas the static methods can access only static data members directly. Whenever we need to make use of non-static members in static members, we have to create the object so that they can be invoked from the static methods. Assessing instance variables and methods. Here, example is the name of the class. MyCount is the instance variable. Increment is the instance method here. Print is the instance method, as all these three members are not preceded by the static keyword. Main is here a static method because it is preceded by the keyword static. Now definition includes that main is a static method and we need to call the non-static member myCount and non-static method increment from main. Therefore, we need to create an object of the class example. Here example C1 is equal to new example is the object creation statement and the object created is C1. Now we have to make a call to the method increment. So how can we make a call to the increment method is with the name of the object, again with the dot operator and the name of the method, like c1 dot increment followed by empty parenthesis and semicolon. This is the function calling statement. In this manner we can call. Likewise, print is again a non-static method and we have called it with the help of object. Again, myCount is a non-static variable, therefore we need to call it with the help of object. c1 dot myCount is equal to 0. Mind it, whenever we make a call to a function, it is preceded by the parenthesis. But or initialize some values to it, we need not to make the use of parenthesis. Now, what are assess specifiers? Assess specifiers are keywords that are used to control the accessibility to the class and its members. The members of the class are variables and the methods. There are four types of access specifiers: private, public, protected, and default. Private, public, and protected are the keywords that will be used, but default is not a keyword that is used. If we don't write any specifier before the class variable or method, it is taken as default. So first access specifier is private keyword. It is used for most of the instance variables. Private variables and methods are accessible only to methods of the class in which they are declared. Declaring instance variables private is known as data hiding. Means when we need to keep our data secure, personal, we need to make use of private access specifiers, and the classes that are declared as private, the methods or the variables that are declared as private cannot be accessed outside the class. Next is public keyword. It exposes variables or methods outside the class. Declaring public methods is known as defining the class public interface. Means when we declare the members as public, it is accessible to all the classes, all the packages in which the class or the members have been defined. So it is available globally. Next is protected keyword. This keyword or access specifier lies between the private and the public. Access specifiers private is most restrictive, public is least restrictive, and protected keyword is used when we need to make use of inheritance. It provides limited access. It provides access to subclasses but not to the classes outside a package. The public keyword is used mostly when we need to have a limited access over the data, and mostly it is used in the case of inheritance. Next one is default access specifier. Default access specifier means we do not explicitly declare an access specifier or modifier for a class, field, method, etc. As I've told you, if we don't write any access specifier, it is taken as default. So there is no keyword for default access specifier. A variable or a method declared without any access control modifier is available to any other class in the same package. The fields in the interface in an interface are implicitly public, static, final, and methods in an interface are by default public. Means anything declared inside a class, that is a function or the variables, are defaultly public. The default modifier is accessible only within the package. Means these are also not accessible outside the package. Next is the crux of what we have discussed in the access modifiers. Private is more restrictive and public is less restrictive access modifier or access specifiers. Here in the tabular form you can see there are four types of modifiers or access specifiers: public, protected, default, private, and the where they are accessible is shown in the first row of the respective table. Class, package, subclass, global. As you can see, public is accessible everywhere within the class and within the package. Subclass globally means outside the package. Protected is accessible in the class only, in the same package, in the subclasses, but not globally. Default is accessible within the class, within the package, but not outside the subclasses and outside the package. Private is accessible only within the class, nowhere else. This lecture was very clear to you. Thank you.